Hello guys, welcome back, and in today's video we are gonna troubleshoot this turbomolecular pump controller, and it's from the manufacturer Agilent, and this controller can be equipped with the TV401 model and 301 navigation from the Agilent, and you can also find such controller with VARIAN models as well. I already mentioned that the VARIAN, formerly it was a VARIAN, and right now it's since acquired by the Agilent, so you can find such products under the umbrella of Agilent as well. So year of manufacture, its serial number, its input, and its origin, and like this. Here we have the model number. Actually, the customer is complaining that it is unable to drive its motor. So here we have its plug. This is controller, and since here it's 220 volt, and the vent port, if you know about this vent port, this is actually connected with the turbomolecular pump, the valve, and here's the connection of the external fan. Here we have the connection for the serial communication, and here we have the J5 that's in and out. These are for some external relays and jumpers. We will discuss this also, but right now first, since he's also claiming that once we power it up, its light is giving the green signal, but it's not able to drive its motor. So we will try to diagnose this from the software. Since we have its software, we will try to connect this controller with the PC through its software, and we also, before starting this, we must have to make some jumpers to give the start signal, and for this purpose we must have to read this. We must have a knowledge about its wiring, because in turbomolecular pumps there is a upper and lower bearings, and these upper and lower bearings must be protected by the thermally protected. So there is a thermostat inside the turbomolecular pump, and some are the thermostats, and in some pumps there is a temperature sensor. So if there is a thermostat, definitely it works as a 0 and 1, and if there is a temperature sensor, it could be a K type or whatsoever the type is, it sends the signal in the form of resistance. So it changes resistance with respect to temperature. So here in this connection, we can find, here we have A, B, C, D, E, and F. So we have the 6 ports, and 3 for the motor, and 1 for earth, 4 and 2 for either for the temperature controller, or like a thermostat, or for temperature sensor. So we will try to consult its manual. Either it's, so if it is a thermostat, then we will definitely try to switch make a jumper. But if it is a temperature sensor, then we will try to see its data sheet, and we will make a we won't make a jumper, we will install a resistance here, because since we don't have a temperature sensor, so we will install a resistance here. So first we have to identify which ports are for the motors, which is for the earth, and which is for the temperature. Okay, and we also have to diagnose this. And first we will go to the software and we will see that how to make jumpers for J5 and description of this. Then we will um, install the necessary things in order to uh, start this controller. So let's move. Okay, now this is the user manual of this turbomolecular pump controller, and here we have the pump description. The turbine of turbomolecular pump is made of a high strength aluminum alloy machine from a single block, and that's the all the science behind this turbomolecular pumps, because it's manufactured through a single block, and its machining is means 5 axis or 6 axis CNC is required. Anyhow, this is not our area, and the nominal speed is 60,000 rpms, is 60k rpms. And we also have one more thing which I would like to mention uh, about this controller. Actually, this is the power supply which gets a single phase input, and it give you the output of 3 phase. And the mode of controller, like it could be operated through 2 modes. The first one is the wire digital analog IO connector, and the second one is either RS232 or 485 connector. So we will try to use this RS232 or 485 via our computer. We will try to connect through the software, and we will try to connect this. But since whenever it is connected with the system, like either with one more thing, that this model, like the TV401, this one TV401, it's MS pump model. So MS mean it's a mass spectrometer. So that's why you can see this pump, it doesn't have any flange, because in a turbomolecular pump we have flanges, either it's ISO-K, ISO-F, um, like DN 100, 150, whatever the flange size is. But this size is, it doesn't have any flange, because it directly inserts toward in the tube of mass spectrometer. So it directly can, here at this collar there is a sealing ring. So at this, here we have the cursor. So anyhow, I will make another video of this turbomolecular pump, because we are also working over this, and over this we will go through this in another video. Okay, and here we have the technical specification of this controller, and rest of the things are like similar. It's a voltage input, frequency, and about the controller, I think it's worth mentioning its pump power output, and it is 54 volt alternating current, 54 volt AC, 3 phases. So it's mean 3 wires will go towards the pump through this controller, and the maximum nominal speed is 60,000 rpms. So at 54 volt at 3 phases, it will give us the rpm of 64. And here's the operating temperatures and its category. So this is not its this is its dimensions, its pumping curve. So here, like, this is the P3 spare for the vent. So if you want to connect a vent pump here, you can connect a vent pump here, sorry, vent valve. And most commonly you use a vent valve here. And this is for the external fan and J5. So this is important for us. And look over here, this is the 15-pin connector. And if you want to connect your pump either through the remote control, so you have to make some jumpers. So this is the 15-pin connectors. It's a D-type connector, and here we have the description of these 15 pins. So what you have to do if you want to start this pump, you have to, like, here we have the start and stop positive signal, here we have start and stop negative, look at the brackets and interlock positive, interlock negative. Similarly, we have the speed setting positive, speed setting negatives. Like if we want to increase the speed and decrease the speed, soft starter option. This is the 24 volt. These 24 volt, it's mean that these 24 volts will be present at its pin number 9. So if you measure with pin number with respect to pin number right, if you want to measure the voltages at pin number 9 with respect to ground, so if you place the multimeter at pin number 24, red at the 24 and pin number 9 and black at pin number 15, so you will get 24 voltages at output. And since these are some IOs, you can like in the case of fault output, if you want to trigger some output signals, alarms and like this, so you can use this. And these are the like output signals. So the signals which are marked with the output, you can use it for some extra or some advanced level of settings. So we are not gonna check this and discuss this. But if you like in a short or in a simple information, if you want to like for this the fault output, if you want to trigger any LED or buzzers, or if you want to halt some operations, you can use this fault output. Okay. And for this start, like for the start positive, so you have to make jumper the start positive with your pin number 9. Sorry, so it's pin number 9. So this start positive will be connected with the pin number 9. So pin number 1 with pin number 9. So pin 1 with pin number 9. So here we have the start stop negative. So remember this, the negative sign. So we will connect this, we should check green. So this negative will go with our ground signal. So pin number 2 with pin number 15. And for the interlock, so here we have the interlock positive, and for the interlock positive you will connect the interlock positive with pin number 9 like this. So even you can make jumper with this here, but similarly 3 with 9. And for interlock negative, that one is the pin number 4. So we will connect the pin number 4 with pin number 15. So again pin 4 will be connected with your pin number 15. So means two wires will be connected with 9. So positive with this positive voltages and the negative with ground. So you will have to make jumpers of you will have to purchase. I will show you in another video on the DB15 connector and how to make jumpers. Similarly, this description is given here, input chart signal, and similar it's also like if if you procure if you have procured this pump new, so you will get a plug and play control like jumper as well. But if it is equipped with another system through operating through a software like this, you can or you are testing this pump in your lab, so you can make these jumpers to start your pump directly. So these were the connections, and let's move to another area so that we can check this and make the jumpers, and we will see the behavior of our controller over the software. So let's move. And about the motor connections, here we have the 3 wires, 1, 2 and 3 for motor, 3 connections, and like B, C and D, and E stands for ground, this is ground, and F and A, these are connected with our temperature thermistor. So if you look here, it's saying that this is NTC type, and it will give us the 30 kilo ohms resistance at 25 degrees Celsius. So I will connect a 30 kilo ohms resistance along with pin number A and pin number F, and we will then try to start the pump turbo this controller, and let's see about this. As I discussed earlier, that it could be a thermostat and temperature sensor, but yes, it's a temperature sensor. It's a thermistor type temperature sensor. So here you can see, if the temperature sensor disconnected, the pump will not start. So this is the thing which is important for you to understand. If like even if this is malfunctioning, if it's not working, it's not giving a right signal from the pump, so it's mean your pump will not start. So this could be a possible problem with the controllers, and because this is to prevent the pump when the temperature exceeds 60 degrees Celsius. So when it reaches the temperature of 60 degree, definitely its resistance will go down, and since the with respect to the temperature, we know that resistance always goes down. If we decrease the temperature, its resistance will go higher, and with increasing in temperature, the resistance will go down. So at 60 degrees Celsius, might be here we have the value of 10 ohm or 50, like it could be any reason, it could be any value, but the purpose of describing this is that it will decrease its value. So if your pump is getting heat and its value is varying, so it's mean thermistor working fine. So what we will do, we will try to connect here the resistance of 30 ohm resistance. We will try to connect a resistance of 30 ohm with these two terminals. So then we will see. So move towards the connection. So here we have the connector with 15 pins, and this connector, we will connect this with our these pins, and as per the description, or as per the the pin out here, the pin number 1 is connected with the pin number 3 and with pin number 9. So pin number 1 is connected with pin number 3 and pin number 9. So 1, 3 and 9 is connected. So here, if we start from here, 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14 and 15. And our pin number 15 is connected with pin number 4 and pin number 2. So here with this is the red jumper, it goes here. So pin 2, 4 and 15. So 3 pins are connected here and 3s are connected here, and we will install this connector here in this orientation, and yes, like this. So even we can use its housing to secure it. We can use its housing to secure it like this. So let's move to the software and see how it behaves. Now I have connected my controller with my computer via RS485 or RS232 communication protocol, this cable, and this is the jumper we already discussed, and no pump found. So right now I'm gonna power it up, and once I power it up, then we have to refresh the pump list. So, and here you can see its behavior. The light is blinking, and now I'm going to click refresh pump list. No pump found. Maybe this could be the reason with this system. Now our controller has been detected with the software. Its temperature 255 degrees Celsius. Oh my god, 255 degrees Celsius temperature, and the communication port number 7 and serial number 1 and status fail. So let's prove it, and it's giving us the status fail because I have not connected these 2 points, like the point A and F, that we supposed to connect with temperature controller, because since these 2 connections will go and will be connected with turbomolecular pump. So I will try to use this resistor, and I will try to use this resistor with here, and then we will see its behavior. Now 22 kilo ohms resistance has been connected with these 2 terminals, and now I'm going to power it up again, and we can also see the behavior of status LED, and now it's stable. You can see slides is stable. Let's move to the software interface and see what's gonna happen. Now here the temperature 33 degrees Celsius, frequency there, status normal. So it's mean it's working absolutely fine, and here status is normal, and in readings we can get the current. The current will be, I think, 0, because we have not connected motor, so there is no power is being drawn. Voltages and output voltages, maximum 54 voltages, power, driving frequency 10 Hertz, and pump temperature value. It will remain fixed because we have connected a resistance. It's not a variable resistance, so it will remain this. And here we have the temporary pump controller. It's showing us a 210, and where 208 degrees is equal to 25 by 1 by 10. So it's mean this pump is working fine. And now we will measure the voltages across these 3 phases: phase A, phase B, and phase D. So we will see that how much voltages we are getting at the output.